So last week we had talked about models for computation, and this week we are sort of continuing that subject in the form of algorithms. And this week we are going to talk about essential properties of algorithms and important algorithms, namely searching and sorting algorithms. And we'll talk about types of algorithms such as greedy, brute force, and divide and conquer algorithms. And then we'll talk about performance of algorithms. And in this context, we will need the concept of growth of functions. And finally, based on the analysis of algorithms, we are going to talk about the classes P and NP. We are going to define them and we are going to talk about what they mean actually. And we will talk about the concepts of NP completeness, NP hardness, and we will conclude with the famous P versus NP problem. Okay, to start with, what is an algorithm? I believe almost everybody taking this class has an idea about what an algorithm is, but essentially, an algorithm is a finite sequence of precise instructions for a computation or the solution of a problem. So some keywords are important here. For instance, you need a finite number of instructions and they need to be precise. So they need to tell you exactly what will happen in case what values are taken by certain variables, let's say, and you need to be able to determine what will happen when a certain instruction is executed. And of course, algorithms usually have input values, and these should come from a specified set. Again, everything should be precise and very specific and very well defined. And of course, some algorithms can produce outputs. Again, this will come from a specified set. Now, some algorithms may not produce outputs, and they might act on the input and modify the input, let's say, in which case we can also see the input as a sort of an output also if it is modified, or it could be a decision algorithm whether something is true or not, in which case the output would be a Boolean variable, let's say, um, or it could be the result of a computation. Of course, an algorithm must be definite, as we have emphasized. It should be general so that it has to work on every possible input value from the set specified for the input values. And of course, it should produce correct outputs. An algorithm also must be effective. And by effective, we mean it should be possible to execute within finite time and finite resources. And the resources here mainly refer to memory requirements. To indicate algorithms on paper, we usually use pseudocode. Pseudocode means computer code which is not really from any programming language. So if you input this to a computer, it would not run, but it tells us or it describes us the algorithm in detail. And here's an example, an algorithm to find the maximum number in a sequence. As I said, this is the algorithm and this is the pseudocode. And it describes us how the algorithm works, but this doesn't really belong to any actual programming language. So if you input this to a computer, it wouldn't really recognize the algorithm. Of course, you'll have to implement it in a specific programming language to actually run it. But in this class and in the context of study of algorithms, the usual way to handle them is to study them on pseudocode. Here, of course, there are many different ways to write pseudocode, and this one here starts with the keyword procedure, and here You have the name of the procedure, or maybe you can call this a function if you like. And these are the inputs, and this is the description or a property of the inputs. And here we start with initializing some variable m to the first value in our list. Remember, we are trying to come up with an algorithm to find the maximum number in a given sequence, and the sequence is given here, a1 through an. So we are initializing some variable m with the first value in the sequence. And then starting from position number 2 to position number n, which is the length of our sequence, we just compare the value m, in fact, which holds the current value of the maximum value, to our current value that we read from the sequence. And of course, if our current value for the maximum m is less than the value we get from the sequence, then we have to update the maximum value. So set m to the value read from the sequence in this case. Otherwise, we do not need to do anything. So when this loop uh, completes, meaning that I reaches n and this comparison is performed, we are done, and we have in m the maximum value in the sequence, so we return it. So in the pseudocode, you see some of the keywords are highlighted, like the for or if or return, etc. And in some resources, you would see and statements. Maybe at the end, you would say and procedure to indicate the end of the algorithm. Or for instance, here, you would see an and if, or maybe um, somewhere here, you would see an and for to indicate the end of the loop. Or in some resources, they prefer to use curly braces, like for e equals to n, a curly brace here, do whatever you would like to do, and complete it with a curly brace to indicate the scope of the loop. In this slides, I preferred using indentation, and these are simple algorithms that we will work on this week anyway, so I believe they will be legible. But do not be surprised if you see other sorts of notation or conventions in other resources too.